Hello, future engineers. Welcome to my YouTube channel. If you're still new to my channel and you like what I'm doing, please don't forget to share my videos to your friends and to your friends' friends, to your younger brothers and sisters who would want to take up engineering in the future, and to your relatives. That's one way you can keep me going, inspired, and refreshed. Now, if you find my videos interesting and important to your studies, also please don't forget to subscribe. Hello, future engineers. Here is another video in Engineers in Progress. I hope that this will help you enhance your thinking skills in algebra, which is also needed in your higher mathematics like calculus and other important uh, subject in engineering courses. So this is about uniform motion problems, and here are the principles. So first, if the moving object is moving with a constant uniform rate, and the uniform rate is denoted by V. So for instance, we have a car here. This uniform rate may also be called average rate or average speed, and the speed is V. Then after a time t, consistent with the speed, the distance traveled by that moving object, would be denoted by d, and d is equal to the uniform rate v times travel time. Now, you will also encounter where the rate is constant, so it is also distance over travel time. And if it is the time that is to be computed, and distance and v are known, then time is equal to distance over speed or uniform speed, uniform rate. Then, by the way, the units of distance may be miles, kilometers, meters, feet. It all depends on the problem. Now, for the speed, it may be in miles per hour, kilometers per hour, meters per minute, or feet per second. Then there is an important unit in navigation, which is the knot, KNOT. One knot is 1 nautical mile per hour. And remember that 1 nautical mile is equal to 6,080 feet. And if it is just mile, it is understood ordinary mile or simply mile. Other terms for that distance is statute mile, and it is equal to 5,280 feet. So again, another speed in navigation, knot, is 1 nautical mile per hour. So we have here another situation. We have an airplane and it travels uh, in a medium where there is headwind. So the headwind is the wind that is on the head of the plane, so it is blowing against the plane. And if the speed of the plane in still air is v, then the effective speed would be v minus the headwind c. And v effective equals v minus the headwind, which is denoted by c. And v is the speed of the plane in still air. C is in general current, or the speed of the resistance to that moving plane or flying plane. Then if we have a tailwind, then the effective speed of the plane would be V plus C. Same is true, same principle if we have a boat traveling against the current, the effective speed of the boat would be V minus C. And if it is navigating or sailing or moving with the current, then the effective speed of the boat would be v plus c. So where v is the uniform speed of moving object in still environment, c is uniform speed of wind or current, then vis-a-vis effective speed of moving object. So let's now have an example to warm up the problems here. So the distance between Cape Town, South Africa and Miami is 7,700 miles. If a jet averages 480 miles per hour between the two cities, what is its travel time in hours? So travel time is equal to distance over speed. Then the distance is 7,780 miles. The average speed or the speed is 480, the uniform rate or speed. So therefore, time equals 7,700 divided by 480, and we'll get 16.04 hours. For the second problem, Traipong traveled from Chicago to Des Moines, a distance of 300 miles in 5 hours. What was his rate in miles per hour? So this time, the average rate is distance over time. The distance is 300 miles and the time is 5 hours. So 300 divided by 5 hours is equal to 60 miles per hour or mph. Problem 3. In a motion problem, the rate is given as x miles per hour and the time is given as 30 minutes. What variable expression represents the distance in miles? So since distance equals uniform rate or speed times time and the rate is denoted by x, the time is 30 minutes or 1/2 hour. So therefore the variable expression is x times 1/2, or it is x over 2. So the variable expression is x over 2 that represents the distance in miles. Problem 4. Agents Mulder and Scully are driving to Georgia to investigate Big Blue, a giant aquatic reptile reported to inhabit one of the local lakes. Mulder leaves Washington at 8:30 a.m. and averages 65 miles per hour. His partner, Scully, leaves at 9 a.m. following the same path and averaging 68 miles per hour. At what time will Scully catch up with Mulder? Remember that Scully leaves Washington at 9 a.m. So his travel time is 30 minutes less than the travel time of Mulder. So 30 minutes is also 1/2 hour. So in order to catch up Mulder, the distance of the two should be the same. So distance equals speed times time, average speed times time. For Mulder, the speed is 65 miles per hour and the travel time is t beginning with 8:30. So 65 times t, that's the distance traveled by Mulder, and the distance of Scully should be the same as this 65 times t, but the travel time of Scully is half an hour less than that of Mulder. So average speed 68 and travel time is t minus 1/2. So 68 times quantity t minus 1/2 or t minus 0.5. Since 68t minus 65t is 3t, 3t in the right side. 68 times negative 0.5 is negative 34. So negative 34 to the left, 34 is equal to 3t. So t therefore is 34 over 3, and that is 34 over 3 is 11 and 1/3 hour. 1/3 hour is 20 minutes. So since the reference time is 8:30 a.m., 8:30 plus 11 and 20 minutes, that would be 19 and 1950 as military time, and 1950 is 7:50 p.m. So again, 11 and 1/3 hour is, so Scully will catch up with Mulder in 11 and 1/3 hours, or 11 and 20 minutes. If we add that to 8:30, that would be 19 and 50. And 1950 is equivalent to 7:50 p.m. So time is 7:50 p.m. Problem 4. Problem 5, brother. By the way, if you want to solve these problems by your own, then you can by pausing the video. I forgot to let you solve the problems if you have now an idea how to solve them, but you can still pause the video for this part here. So problem 5, two steamers leave a port on a river at the same time, traveling in opposite directions. Each is traveling 22 miles per hour. So how long will it take for them to be 110 miles apart? Since the two steamers travel in opposite directions, the distance would be the sum of the distances traveled by each. So distance equals d sub 1 plus d sub 2, where d sub 1 is speed of the first steamer times travel time t1, and t sub 2 is speed of the second steamer times t sub 2. But t sub 1 equals t sub 2 equals t, as well as v1 equals v sub 2, because it is mentioned here each is traveling at 22 miles per hour and they leave the port at the same time. So their travel time and their speeds are equal. So that distance after a time t is 110 miles. So 110 equals 22 times t plus 22 times t. So 110 equals 44t. So t is 110 over 44, and that is 2.5 hours. Problem 6. A train leaves Kansas City, Kansas, and travels north at 85 kilometers per hour. Another train leaves at the same time and travels south at 95 kilometers per hour. So how long will it take before they are 315 kilometers apart? So this problem is similar to problem 5, except that this time they have different uh, speeds or rates. So distance is still distance 1 plus distance 2, and it is also speed of the first train times travel time of the first train, and speed of the second train times travel time of the second train. Since both trains leave at the same time, therefore they have the same travel time. The total distance is equated to 315. So 315 equals 85 times t plus 95 times t. So 315 equals 180t. So therefore t is 315 over 180, and that is 7/4 hours or 1.75 hours. So the two trains will be 315 kilometers apart after 1.75 hours. Problem 7. Lois and Clark are covering separate stories and have to travel in opposite directions. Lois leaves the Daily Planet at 8 a.m. and travels at 35 miles per hour. Clark leaves at 8:15 a.m. and travels at 40 miles per hour. At what time will they be 140 miles apart? So this time, this is similar to problems 5 and 6, but their travel times will be different as well as their rates. So therefore, we use the same formula, distance equals d sub 1 plus d sub 2, and distance equals v1 t1 plus v2 t2, where v1 is 35 for Lois, and travel time is, just call it t, and our reference time, departure time, is 8 a.m. While for Clark, the rate is 40 miles per hour, and the travel time of Clark is 15 minutes less than that of Lois. So, and 15 minutes is 1/4 hour. So therefore, distance, which is 140, equals 35 times t plus 40 times travel time of Clark is t minus 1/4. 1/4 hour is 15 minutes also. So 140 equals 35t plus 40t, that's 75t minus 10. So equals 75t minus 10, 140 plus 10, 150 equals 75t. So solving for t, 150 over 75, and that is 2 hours. So for the time, they will be 8 plus 2 hours, so that would be 10 a.m. They will be, Lewis and Clark will be 140 miles apart at 10 a.m. Then problem 8, this is our last problem. In this video, Julescent can get to school in 15 minutes if he rides his bike. It takes him 45 minutes if he walks. His speed when walking is 10 miles per hour slower than his speed when riding. What is his speed when he rides? So let us denote the distance between Jolson's home and the school as d, and d is equal to, if he travels his bike, the speed is denoted by v, and the travel time is 15 minutes or 1/4 hour. So distance equals speed times time. This is the speed of Jolson when riding his bike. So d is v times travel time 15 minutes or 1/4. So therefore d is v over 4. D is also when Jolson walks, speed in walking times time, which is 45 minutes, and 45 minutes is 45 over 60 or 3/4 hour. So v sub w times 3/4 hour d. So d is also 3/4 of vw. And it is stated here that Jules's speed when walking is 10 miles per hour slower than his speed when riding. So that means v sub w is v minus 10. So equating this to d, v over 4 equals 3/4 vw, and cancel out 4, so v equals 3w, and this time we replace vw by quantity v minus 10. So 3v minus v is 2v in the right side. 3 times 10 is 3 times negative 10 is negative 30 to the left, so 30 equals 2v. V therefore is 30 over 2, so v, the speed of Julescent when riding his bike, is 15 miles per hour. So that's it for this video, and I hope that you were able to follow the explanation and solutions. These are just light problems to warm up. We'll have challenging problems as we move on.